Hello and welcome to our channel. In the last video of the STL series, we learned about the data structure stacks. In this video, we look at a new data structure, that is queue. Queue is a data structure or a container adapter that operates in a first in first out or FIFO format. A container is an object that holds data of the same type. An easy way to visualize the FIFO structure is by taking the example of a disciplined queue in a supermarket. The first person to come at the counter is the first person to leave the counter. In the same way, the first element to be inserted in a queue will be the first one to come out of the queue. This is the syntax to initialize a queue. The syntax contains three parts. First one is the keyword. The second part is where we write the data type of the elements that we want in our queue. It could be integer, float, character, or any other user-defined data type. And the third part is where we specify a variable name for the queue. So there are different ways to initialize a queue. The first one is by using member functions for inserting elements. And we use push function to do the same. The second way to initialize is we can first initialize a different container like a vector or a list and then initialize a queue with the help of the container that we previously initialized. And the third way of initializing a queue is that we can initialize a queue1 and then we can initialize a queue2 with the help of the first queue that we initialized. We'll look at a detailed code for all of this in the next few minutes. These are some common and very basic functions that can be performed on queues. To the right, you can see a visual representation of a queue. Unlike stacks, queues have both ends open, one of which is the front and the other one is the back. Now let's get to the coding part of it. So this is a basic code for initializing a queue. This is the syntax which contains the keyword, that is queue. The data type here is integer because I want all my elements in the queue to be integers, and this is the variable name that I'm using for my queue. I am inserting all the elements one by one using the push function, and I want my output, so I'm using the queue.pop function to get the output of my queue. So I will run the code. And as you can see, we have all the elements of our queue as the output. One thing to note here is that the pop function removes the element from the front of the queue. So if we check the size of the queue before and after using the pop function, it will be as follows. This is the code line which gives us the size of the queue. So when I run the code, we can see that the size of our queue is 5 before using the pop function, and the size of the queue is 0 after using the pop function because the pop function has removed all the elements from our queue. Moving on to the second way, I am first initializing a container. In this case, I am initializing a DQ, which is basically double-ended queue. In this DQ, I am inserting all the integers starting from 0 up to 5. And with the help of this DQ, I am initializing my queue. And I am adding an additional element, that is the number 10 in my queue. And I am using the pop function to get the output. So when I run this code, I see that all the numbers from 0 to 5 and the additional element 10 is in our queue. The third way to initialize a queue is quite similar to the previous one, only instead of a DQ, I am initializing a queue, a first queue, that is Q1. I am pushing 3 elements, that is 10, 20 and 30, and with the help of Q1, I am initializing Q2. So when I run this code, we see all the elements in Q2. Now we look at some functions that can be performed on queues. I'm initializing the queue and inserting elements just how we did in the previous code. So So now let us look at all the functions one by one and see their functionalities. The very first function is q.front. It returns the first element or the element which is at the front of q. The second function is q.back, which returns the last element or the element which is at the back of the queue. The third function is q.size, which gives us the size of the queue, basically the number of elements that our queue holds. And the last function is q.empty, which tells us whether or not the queue is empty. So this function returns a boolean value which will be 1 or true if the queue is empty, or it will be 0, that is false, if our queue is not empty. So we'll run this code and see what output we are getting for each of this function. So as you can see, q.front is giving us the output 1, which is the first element that we pushed in the queue. q.back is giving us the output 25, which is the last element of the queue. The size of our queue is 5, and q.empty is giving us the value 0, which means that our queue is not empty. Moving on to the last function that is performed on the queues is the swap function. So as the name suggests, the swap function swaps the elements of two queues with each other. For this, I am initializing two queues, Q1 and Q2. For the first queue, I am inserting the numbers from 0 up to 5, and for the second queue, I am inserting numbers from 10 up to 15. With the help of swap function, I am going to swap the elements of Q1 and Q2, and I am going to print these two queues. So when I run this code, we can see that the elements of Q1 are now in Q2 and the elements of Q2 are now in Q1. So this is all about queues and the functions used with queues. Thank you for watching the video.